Thank you. Good afternoon. In my opinion, the trade tensions between the US and China have little to do with trade and have a lot more to do with who can design and manufacture advanced semiconductors. The semiconductors I'm talking about are not the 14 through 16 nanometer semiconductors that are in your basic cell phones, but the real technology now is down to 7 nanometers, and this is what's going to enable machine-to-machine communication, robotics, advanced weaponry, artificial intelligence. The semiconductor industry is a $412 billion industry, but really there's only 6 companies that really design these advanced chips, and 3 of them are based in the US. China has pledged $150 billion their own to advance their semiconductor industry. In my opinion, this is going to lead to more advanced, more sophisticated supply chain attacks if these global tensions continue. But we don't just need that to be worried about supply chain attacks. Our own government here in the United States, NIST, has been pointing out for quite a while now that supply chain security attacks are the #1 attack vector, the #1 type of attack that attackers will choose to use. This means we need to up our game. We all need to up our game and start thinking along the lines similar to what the nuclear industry has been doing for the last 10 years, maybe more. So why supply chain security attacks? It's because our supply chains think in terms of lean manufacturing. They have not been educated and trained to understand that cybersecurity is a core part of a quality product. It's because of the extensive link ecosystem that we have with our outsourcing, globalization, and multitudes of suppliers and sub-suppliers that make it such a large, rapidly scalable location to launch an attack from. It's because the thinking center of the organization is generally far removed from the edges of the enterprise, particularly if you have a vulnerable third-party supplier or sub-supplier. And these type of attacks can be optimistically timed to include ransomware, intellectual property loss, or destruction. So we already know this is here. We've had advanced threat actors like Crouching Yeti, Energetic Bear, and Dragonfly that have been around for quite a while and continue to remain here to this day, still targeting industrial manufacturers as well as our customers. Some examples on this slide: Stuxnet, German steel mill, and even the Trans-Siberian pipeline all demonstrated that this stuff is real, can lead to physical explosions. Target simply demonstrated how tightly coupled our ecosystem is, being able to pivot from a heating system to the payment card system. And OPM, we had an attack with the largest intellectual property theft known to the world. And then Petra was equivalent to a Category 5 hurricane in terms of cost and impact. But you guys are a smart audience, you know about these. But this is the #1 attack vector. And when we take a step back, when we talked about Digital Ghost, we talked about what's the plant's mission here, right? You guys know this. This is about health, safety, and the environment, and then process efficiency, all right? If you think about it, where does a plant's policies and procedures derive from? Do they derive from NIST, NERC, IEC? No. It's the process control description and the control system narrative that defines exactly how this product moves, with lots of sensors, actuators, control nodes laced around the process control. Any one of these, if falsified, would potentially have a very devastating impact. If the gas turbine speed had falsified its signal to the DCS operator and the safety system were compromised, well, he may try to increase the speed. But at the end of the day, this plan is not designed around just cybersecurity, and safety is not synonymous with security. we have to understand beyond just the HMIs and the networks, the underlying process underneath a plant. When we think about our global supply chain and where all this is coming from, this all matters. So I'm going to try to demystify the supply chain security conversation with giving you some ideas, both you can do inside your walls and outside your walls. But I want to back up and point out that cybersecurity is not an engineering domain. It's a domain where we have a human, intelligent adversary. So we have to think very horizontally about this problem. And I start off with the first step. This industry that we're in, industrial control systems, is a decade-long measurement, right? 10 years, life cycles. That shouldn't be subject to any point solution that's going to change in the next 1 year or 2 years. And there's a lot of various solutions out there, point solutions. It's important that your partner has a point solution avoidance and starts thinking long-term for the life cycle of that plant. And it's also important that they come with that vision and mission alignment about environmental health and safety, as well as expertise, not just in cybersecurity, but understanding those various process controls, whether they be in mining, aviation, oil and gas, nuclear. And we believe that those technologies need to be built for the industrial control environment, not just IT technologies put on top of industrials. So how do you qualify these long-term strategic partners? This is not trivial. This is important to identify for the life cycle of your plant in the day and age that we live in today with rapid change. Are they willing to hold executive-to-executive meetings? Are they willing to do proof of concepts? Are they willing to demonstrate new product certifications with you? For your vendors and your suppliers, these are some of the questions that you may consider asking. And probably more importantly than anything else, number one question is, do they have a centralized security supplier quality department? Okay, your vendors, your suppliers. This is the team that creates the risk-based methodology used for all of your suppliers. This is the team that creates the vendor-approved list. Another very important word. Is there a vendor-approved list? Without that, your suppliers will go and choose different parts. They may choose new code. They may choose cheaper things. They could be vulnerable. This is the same team that is basically linking your thinking center of the organization, this chief security officer, with the edges of the enterprise, because they're setting that baseline throughout the whole enterprise. And we believe that the vocabulary that you use, whatever vocabulary you adopt, NIST or somewhere else, should align with your suppliers as well and cascade down to them so that you're speaking the same language. There's lots of different ones to choose from. Code. Obviously, we want to protect code, but how do we protect code? What is a code integrity warranty? How is that written in your SOAs and terms and conditions? There should be an expectation that it's cleaned, written back to us free of charge. The software development lifecycle needs to identify exactly how this is done. How do they make sure code is clean? And there should be warranties against any restrictive devices. And then back to the supplier's vulnerability management plan. This is critical in identifying exactly what the SOAs are going to be for returning that code to us, because our customers are expecting sometimes less than 30 days to receive revised code. So setting those terms and conditions and those SOAs or mean times to bring that code back to us clean is very important. And these are the folks that make sure that the terms and conditions are all there to prevent the supplier from making public statements. We don't want a vulnerability to make its way to something like DEF CON or Black Hat, right? This has to be responsible disclosure. And then secure by design. We, within GE, within Baker Hughes, we all share a secure by design philosophy. And that secure by design philosophy is what we expect our suppliers and sub-suppliers to use as well. And this falls through all the life cycle, from the requirements phase, from making sure that security user stories are developed between all sprints and releases, from attack surface analysis, from code testing such as static application code testing and dynamic application code testing and fuzz testing. All these are expected of our suppliers. You know, when they get to the test phase, we would like to see product certifications, process certifications, independent certifications. And how does that product come to us? This is often an area of an attack point. How do we receive products in a secure manner so that we know that they haven't been tampered with? We use things like encryption. We use hash integrity checks. We use secure packaging tape and the like. And does that supplier have an incident response plan? Because at the end of the day, things do break. And I'm going to take a step out there and say that no open source software. The theory is that open source software is reviewed by lots of eyes. Lots of people are out there reviewing open source code, but we have two examples, really good examples, of where 25-year-old code was not being reviewed by anyone. Shellshock and Heartbleed. Open source code, I understand it's used a lot in places like Apache and various places. It's very useful, but we require our suppliers to provide written authorization to use open source code, because open source code is much more easier for supply chain security attacks to take root. Intellectual property, and this ties back to open source code, is the balance sheet of the company. And our terms and conditions require our suppliers to disclose all physical and immaterial sources that are used to create that product. All right. And then finally, after we've done these SOAs and terms and conditions, and we have our centralized supplier quality department doing their on-site assessments, we can't just stop there, though. We have to think more broadly, because there's so many different avenues this can take root in their supply chain. So how do we commission securely? We learned this from the nuclear industry. As soon as we provide electricity to a customer product, it becomes a critical digital asset. That means that it's protected as if it was on the customer's premise. We have cages, literally, where our customers and our project teams sit in with badge access control, physical cameras, USB protections on the inside to prevent USBs from being inserted, as well as MAC address filtering and things like that. All designed around a certified project team. This is part of commissioning securely. This should be expected by you and through your vendors and through your suppliers. And then once a product leaves us and we ship it to site securely, there's obviously this continuation of updates. And a lot of times people think patches, and patches has kind of become a commodity, right? It's still critically important that that partner has a validation lab where they are consistently doing cybersecurity checks, doing things like purple teaming, red teaming, working with labs, getting those updates not just on software but also on firmware back to their customers. And it's becoming even more critical to do it in a timely manner. Look at Google Chrome. Google Chrome gets updates potentially daily. By the time you find a vulnerability in Google Chrome, it's already changed its code base. There's a patch now philosophy that is slowly making its way into our industry as well. It's a very protective measure, and it provides an immediate ROI. Lots of additional considerations. Let me kind of wrap this up a little bit. You know, depending on what it is that are, it could be a controller, it could be a critical component, you may need to think about even stringent, more conditions that you need to place on your suppliers. This could be everything from background checks on employees, making sure that their roles, when they're changed, that you are notified of those role changes. All right? This could be managing the service depots where this product sits, because the longer a product sits, the more risk for tampering increase. This could be about the returns department. How does the returns department work? Does the returns come into the supplier in a secure way? Is it reused and put back into the life cycle? All right, that's a great place for hacking. These are just additional considerations that you may need to consider. You may want to have the hardware and software all developed under the same roof. And lastly, my chief security officer has always told me that a A real company is how they respond, how quickly they can respond. You know, within GE, we have a formalized product security incident response team that delivers out messages to our customers timely regarding any vulnerabilities related with our products. But we also take it a step forward now. We have some customers that absolutely cannot wait 4 hours for a human to get on site, whether that be for controls-related issues or cybersecurity-related issues. Remote connectivity and doing it securely is a requirement in order to remain competitive, in order to remain secure. Incident response, we believe, is the fastest growing market, and so this is a space that we plan to spend a lot more time in. So I hope at a high level, without going through the whole nuclear regulatory standards, you got an idea of some of the common sense questions to measure vendor trustworthiness, okay? And identify that long-term strategic partner that's going to be there for you the life cycle of your plant. And we believe it's important to do quality checks, not just within the products themselves and through terms and conditions, but both inside your own walls. Thank you.